Hello again. So in this second part of the videos, we're going to be talking about irreducible polynomials, which can be thought of as the analog of primes. So let me first remind you how we define primes in the integers. So in Z, P is a prime if the only divisors of P are plus and minus 1 or plus and minus p. In our current terminology, plus and minus 1 are the units in the integers, and we'll introduce a new terminology for plus and minus p. We say two objects, two polynomials. So let's deal with polynomials. We say p of x and q of x are associates if q of x is equal to u p of x for some unit u in so that's an F star. So plus and minus p are the associates of p. Now, so in analogy to this definition of prime, we define, we say, a polynomial p of x is irreducible if the only factors, factors of p of x are units, so that's the analog of plus and minus 1, or associates, the analog of plus and minus p. Now remember, we had another characterization for prime numbers. We said that if p is prime, so again in Z, if p is prime, then p dividing a product implies p divides one or the other in the product. We have the same thing, and so this is sometimes used as a characterization of primes, and in fact later on we will eventually define irreducibles this way and primes this way. And in some rings they are different concept. Irreducibles and primes can be different. So let's see if this property here also holds for polynomials. So if p of x is irreducible in some polynomial ring with coefficients in the field, then p of x dividing a product implies p of x divides 1 or p of x divides the other. So let's even call this a theorem. And our proof is exactly like it is in the integers. If p of x divides a of x, then we are done. It divides one or the other. And if not, then we can say that the GCD of p of x and a of x is equal to 1. Because the GCD of p of x and a of x is a common divisor, so in particular it's a divisor of p of x, which means that it's either an associate of p of x or it's a unit. It can't be an associate, because if it's an associate we have p of x dividing a of x, so it must be a unit, and so the GCD is 1. And that means we can write 1 is a linear combination of P of x and A of x. And as we did before, we multiply through by B of x, and we get P of x. Let me use commutativity here and write it that way, plus A of x, B of x, T of x, and let me group it this way. And since P of x divides this term here, because P of x is right there, and we were given that P of x divides the product A of x, B of x, we get out of this that P of x divides B of x. So if P of x doesn't divide A of x, then it has to divide B of x, and we're done.